In 1.7, we're going to kind of dive deeper in some characteristics of functions. And so I want to kind of start out with some vocabulary and kind of build as we go along into this section. This does have longer notes for it if you're printing off the notes. That's because I wanted to make sure I had some really good pictures and examples as we go through this. So the first thing I want to talk about is something called a relation. A relation is very basic. It's just a set of ordered pairs. So you can see here I've got ordered pairs, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. This would be a relation. It could also be an ordered pair like this, odd 1, even 2, just anything that's kind of grouped together. It's just a set of ordered pairs. We're not sure why they're a set until we kind of further dive in, but it's very basic. But we need this idea of relation to do part B. Function is the more important one. A function is a relation, so set of ordered pairs, that assigns a single value in the range to each value in the domain. Meaning your x's don't repeat. We're going to talk about this idea of domain and range here in a minute. But it says, notice I took my same relations from the relation definition, and I want to show you how these could or could not be a function. Basically, your x's can't repeat. And so you're going to come in here and say, okay, here's my x's. 1, 2, 3, 4, 5. Never did those repeat, so I'd be like, yep, this would be a function. Notice I'm not concerned with what the y values are. Only concerned with the x values when I'm talking about the idea of a function. Looking at this one, here's my x values. Odd, even, odd, even, odd. You can see odd repeat itself. Even repeat itself. So it only takes one bad apple to spoil the whole bunch, but this one, by a few means, is not a function. Now, looking at a function in ordered pairs, that can be kind of tedious, looking at every single ordered pair, especially when it comes to a graph. So when we're looking at functions on a graph, we consider something called the vertical line test. This says if we can draw any vertical line that intersects the graph more than once, then the graph does not define a function because x value has more than one output. So basically, if you could take your pen and move it across this function, and it only intersects it once, then yep, you're a function. But if you find one line where it intersects more than once, then it's not a function anymore. It could be said that, look, if I draw it right here, it's a function. Well, again, it's not finding one good line. It's if you could find one bad line. You can see right here, this would not be a function. Likewise, like right here, this would not be a function. Because it would be the case of these x's repeating. If I were to look at, say, these x values here, this could be at x comma 2, 2 comma 2. This may be at 2, negative 2. Notice those x's would repeat, and that's what places them vertical on top of each other. So let's look at these examples, and let's see if we can figure out if they're a function or not. So again, sometimes I just take my pen and I move it across. You can see it's only intersecting this function at one point. Same thing with this one. Only intersecting at one point, no matter where I put my pen or my vertical line. Now here, if I put it right here, you can see it would intersect it at 2 points. So yes, this is a function, yes, this is a function, and this one would not be. So the vertical line test is really handy. Also, looking at ordered pairs helps us. Furthermore, some characteristics that we face are things that we've already kind of mentioned. Domain. Domain is all the possible x values in the function. It's also called the independent variable or an input. Range is all the possible y values in the function. We also consider it the dependent variable or the output. So consider these same two relations or functions, if you like, we were looking at before. Say I want to do it. Well, first of all, 1, 2, 3, 4, 5. We could say, yep, this is a function. Then let's look at the domain. The domain would be the set of all possible x values. So I have 1, 2, 3, 4, 5. They're typically in numerical order and only listed as possibilities, not who they're paired with or how often they occur or what order they occur in. If I wanted to do my range, it would be all the possible y's. So it would be 2, 4, 6, 8, 10. So I'd put them in numerical order, only putting them once. Again, when I split into domain and range, it tells me possibilities. It doesn't tell me who they're paired with, how many times they occur, or when they occur. You can see that better in the next example. Odd, even, odd, well, right there my x's repeated, so not a function. If I'm looking at domain, it's all my possible x values, odd, even, odd, even, odd. So I would just put them in order. In this case, alphabetically. Even and odd are my two possibilities. It does not tell me that even occurs twice or odd occurs 3 times or who they're paired with. It just tells me possibilities. Range-wise, I'm looking at 1, 2, 3, 4, and 5. And again, I just put them numerically in order. And even if they exist more than once, when I'm listing out the set or the possibilities, I only list it once. Now, you might encounter some of these functions where it just talks about inputs and outputs. Well, your inputs, that's your domain. And so, like for this one, I just say domain is PQR. Or, like this one, I would say the domain is PQ. Range-wise would be your output, so I would just say MN. Again, it doesn't talk about who they're paired with, how often they occur, it just talks about your possibilities. Likewise, this range might be XYZ. Now, if we're talking about if it's a function, remember your x's can't repeat or your inputs can't repeat. So notice there's only one arrow coming out of these, so check, that would be a function. One arrow coming out of PQR, check, that would be a function. Notice here, 2 arrows are coming out of Q. Inputs is my x's. So in this case, my x is repeated, so this would not be a function. So I want to show you the different ways you may see them in a graph, in ordered pairs, or maybe in one of these little tables. And then here's a couple of examples as well. It says the table below lists the 5 greatest baseball players of all time in order of rank. Is the rank a function of the player name? Rank, function of the player name, meaning does your rank happen more than once? Do your ranks repeat? And they don't, so this would be a function. And then it says reverse of that. Is the player name a function of the rank? Well, you can see the player names do not repeat. My x's do not repeat. So again, this is a function. Now looking at these down here, these are inputs and outputs, just like what you saw on the table with the arrows, but they've lined them up in a table. Notice your inputs are your x's, outputs are your y's. So these would be your domains and your ranges. Now for it to be a function, my x can't repeat. 2, 5, 8, my x's didn't repeat, so that's a function. Negative 3, 0, 4, x's didn't repeat, that's a function. I'm not concerned with my output repeating. We'll talk about that here in a minute. Last one, 1, 5, 5. My 5's repeated, so this would not be a function. So I wanted to show you all these different ways that you're going to be approached with it, so no matter what it looks like, you know what you're looking for. The next part comes into function notation. Now we're growing up, we're in college algebra, we're expanding what we know. We're no longer going to just work with y's. Now we're going to call it f of x, or function notation. It defines a function named f. It's read as y is a function of f, x. The letter x represents the independent variable, and the letter y, or f of x, represents the output or dependent variable. So instead of like in grade school looking at y equals 3x plus 4, we're now going to call it f of x equals 3x plus 4. So we're just changing the name of this variable. Just like if your name was Elizabeth. That might be your formal name or f of x, but your friends might call you Liz or Lizzie or Beth, and that might be a nickname for you, but still referring to the same person. The same is true with y and f of x, just changing the name of what it is, but still the same equation or function. Next, we're going to talk about one-to-one. We got relation, we built that upon to give us function, so now one-to-one. A one-to-one function is a function in which each output value corresponds to exactly one input value. So with function, our x's can't repeat. With one-to-one, we want to say our y's don't repeat. So kind of a more special function. And it says if you draw any horizontal line that intersects a graph more than once, then the graph does not represent a one-to-one function because the y's would repeat. So looking at these examples here, function, you do vertical line test. One-to-one, you do a horizontal line test. Notice if I were to draw a horizontal line here, it would touch more than once, so this would not be one-to-one. If I draw horizontal lines anywhere on here, this would be one-to-one. If I draw a horizontal line here, you can see that this would also not be 1-to-1. So kind of similar to what you're doing with function, but you're going to kind of take it in reverse. All that being said, let's start evaluating some of these functions. Now, it is going to take into function notation. So instead of saying y equals this equation, we're using h of p. When we go to evaluate, we use this function notation because it helps us to see what we're evaluating as. Instead of saying when y equals 4, find the value of p, it's going to say h of 4, meaning everywhere you have a p, put a 4. So I like to go ahead and write my equation without the p in there and just put blank parentheses, and then take your 4 and plug it everywhere you had a blank. Then from that point, we could just evaluate to give me 16 plus 8 or 24. So evaluating a function you absolutely probably do know how to do, but it's this notation that's going to kind of hang you up. And it's just shorthanding for plugging in different values. So we're going to do 4 parts to this one. So let's see if we can do this together. For the function, evaluate each of the following. So the first one says f of 2. So everywhere we have an x, they want us now to put a 2. So I like to write my equation and everywhere x was, put a blank parentheses. Then where you have x, I'm going to plug 2's in. They took their x and changed it to 2, so we're going to do the same for the rest of it. So again, not a problem. I just evaluate. That gives me 4 plus 6 minus 4. So that gives me 6 for a final value. Part 2, they're going to amp it up a little bit. Now again, instead of x, they want us to put an a. So I'm going to put parentheses everywhere I had an x. And then I'm going to put an a in all those parentheses. Now with this one, I really can't do much more to it. If you like, I could just call it a squared plus 3a minus 4. But at the end of the day, that is f of a. I can't do anything else with it. Number 3, f of h, a plus h. So you can see we now put an x, and then I'll put an a plus h everywhere you have an x. So again, I'm going to put parentheses everywhere I have that x. I'm going to plug in a plus h. Now with this one, it has a little bit more work to do. I'm going to go ahead and multiply all this out. So a plus h squared means a plus h times a plus h. So I definitely use our rules of exponents here. A times a is a squared plus ah plus plus h squared. I'm going to distribute the 3 here, so plus 3a plus 3h minus 4. And then I'm going to combine anything I could, but there's nothing really I can combine here. So this hairy looking thing here is f of a plus h. Now I did all that work because number 4 is going to have us put pieces together. It wants us to take number 3 minus number 2 and divide it by h. You can see we've already done these individual pieces. So I'm going to go ahead and write that. So I'm going to take f of a plus h, which I know to be equal to all of this. We've already done our legwork for this. And, excuse me, I could put those two together. Minus, I want to subtract f of a, which notice we already found f of a up here, a squared plus 3a minus 4. And I made sure to put minus this whole grouping because I'm doing minus the whole grouping all over h. Now I am going to clean this up a little bit more. I'm going to distribute this negative throughout here, which gives me positive, negative, negative, positive. And I'm going to combine like terms. Negative AH and positive AH cancel. Negative 3A and positive 3A cancel. And positive 4 and negative 4 cancel, leaving me with 2AH plus h squared plus 3h all over h. You can see they all have an h in common. 2a plus h plus 3 all over h. Then our h is canceled. So this last part of evaluating, definitely, you're putting all of your algebraic skills together here. But the important thing about this problem is I wanted to emphasize on how we are just evaluating, we're just plugging something in for x, and then seeing what we can get as a result. All of this was factoring, distributing, combining like terms as you went.